Good morning. My name is Norman Euler and here to do a teaching presentation for the Sierra College welding instructor position. I'd start my class off with a question of the day, and that in an introductory welding course, we're going to be addressing the three factors that affect heat in oxy-fuel welding. At this time, I would offer the class an opportunity to contribute to the question of the day and ask about whether or not there is understanding what predetermined knowledges they might have, and move on into discussion of that question of the day. Once we get through the question of the day, we're going to start to talk about our lecture and then move into the lab. We would talk about what main factors affect heat input and how they relate to proper fusion between filler metal and base metal. To address those factors, we want to talk about different components of an oxy-fuel welding system. And one of those things that I talk about is tip size within the class. Three main tips that I have students practice oxy-fuel welding with is a double aught, an aught, and a number one. And in the lab, we address those three different exercises with one, doing a puddle on 16 gauge mild steel and have students run beads doing that. With an aught size tip, we practice a corner weld where the students will set up two pieces of 16 gauge mild steel coupons and run a bead down the corner. Use a number one tip for running a filler rod bead and have students practice all three of those welds on basically 2x4 mild steel coupons. Talk about setup in the oxy-fuel welding system, in that line pressure is very important for affecting heat and getting a good joint on welding mild steel with the oxy-fuel type welding practice. Line pressure recommendations there: oxygen 5 to 7 and acetylene about 3 to 5 psi. Importance of adjusting the oxy-fuel flame also affects heat and fusion between base metal and filler rod type applications, in that you need to properly adjust it. After lighting the oxy-fuel torch, which when students or the welder goes to light the torch, you have just an acetylene gas. You don't have a mixed gas at that point. And so when you light your acetylene, you want to adjust the acetylene to where soot just starts to dissipate. When you're just burning acetylene by itself, you start to add oxygen at that point, and you watch as your oxygen mixture comes into the flame. You want to adjust it from what is known as a carburizing flame down to a neutral flame. And you can see as you adjust the oxy-fuel torch, what I describe as the inner cone or the inner flame will start to shorten down into the cone of the flame, and then you basically achieve your neutral flame. This part of the cone or flame is not highly visible when you are adjusting it. If you add too much oxygen into the mixing chamber or the torch, you end up with what's called an oxidizing flame. And again, this flame adjustment is very important in terms of setting up your oxy-fuel equipment. Other things that affect the fusion between base metal and filler rod is torch technique. And this is something that has to be practiced in the lab. Students have to have the experience of developing their own individual torch technique. And this is where that hands-on application is extremely important. Students learn to hold their torch correctly, in that the torch tip needs to be at a 45-degree angle. Another very important thing is that students tend to have a hard time initially determining this distance above their base metal, in that when they have the proper tip size and have the flame adjusted correctly, then developing the dexterity in terms of holding the cone of the flame approximately a 1/16 to an 1/8 of an inch above the base metal as they're moving in a counterclockwise fashion. Developing that torch technique is very important. And then the third factor there, which is very important, is travel speed, in that in the welding process for a right-handed individual, you'll develop the counterclockwise motion, the practice of maintaining that torch tip angle and the intercone distance, and then basically your travel from right to left, in that it's just opposite from writing. If you're a right-handed person, is that you need to develop that torch technique traveling counterclockwise from right to left. Filler rod application, I explain to students, is kind of like patting your head and then rubbing your belly, in that it takes a lot of practice technique in terms of maintaining your equipment when you start to add in the other component of welding with a filler rod and an oxyacetylene setup, in that you have to hold your filler rod with your left hand, maintain the feeding of that filler material into your base weld along with playing your torch. And it's just a matter of practice in the lab to be able to develop those techniques. The two types of filler rod or sizes of filler rod that I like to use out in the welding lab is a 3/32 or an 1/8 inch rod. Those rods are typically about 3 feet in length. R45 is the type of rod that I usually do, and I prefer having students using copper coated rod over grease rod. The copper coated rod is a little more expensive, but tends to not get as many contaminants into your weld if the rod is stored for a very long time in the shop. As you can see here in the illustration with a filler rod type application, you have your torch tip coming in, maintaining that distance as we spoke earlier, with the inner cone of the flame about a 1/16 to an 1/8 of an inch above your base metal. And then here it illustrates maintaining the molten weld pool. One of the most important things in practice in terms of having students do these kinds of things out in the lab, I think where oxyacetylene welding is still really important, is that it teaches students to maintain a weld pool. It illustrates to them the importance of having the proper heat introduced into the weld. And that's the beauty of learning oxyacetylene welding. Here's an illustration with students again, where out in the lab, it's what gives them that practical experience of learning what to look for in the strong characteristics of a weld. And that if you look up here on rows 1 and 4, those are basically all the input factors illustrated that you would use or see in a good oxyacetylene weld. You want to maintain your weld pool about 1/4 of an inch in diameter, which there's no direct measurement illustration up here on our slide, but you can see the uniformity within row 1 and row 4. We have a little bit of elongation in the weld there, which shows that you may have increased your travel speed a little more than what you should have during that weld. But rows 2 and row 3 should illustrate what improper heat would look like in an oxyacetylene weld. And that in row 2, you can definitely see that hopefully there's too much heat there, and that you see some weld pools that are burning through your base metal coupon. You can see where you may have gotten your inner cone or your flame down into the weld pool too much, and that we start to see some inclusions here. And then in row 3 is a good illustration of what too little heat would look like to the student practicing out in the lab and that you see some real inconsistencies in your puddle bead there, and you can see where the weld pool basically stopped within this bead. Out in the lab, after you illustrate to students the subject matter that they would need to be following out there, this is where the real learning takes place. Is that again, I like to start students off with, after we've gone through, introduced them to the oxyacetylene welding unit, get comfortable with lighting a torch, adjusting your line pressures, and getting acclimated with all the equipment, is that run a bead without filler metal. Again, I prefer to use 16 gauge mild steel 2x4 coupons, and have the students practice running several beads without any filler metal. Next is the application of a corner weld, where we're actually going to be joining two pieces of metal. And again, students really learn the importance of playing a torch in this type of a scenario, and fusing two pieces of metal together, and you can really get a good exercise there on what the weld pools look like. As we increase in skill, increase in technique, have students move on to doing some type of a filler rod bead. Not necessarily a T-weld. This is a little more advanced than just running flat beads, but definitely a good exercise in developing practice with an oxy-fuel welding setup and learning the importance of fusion and heat within the weld. Questions, always good to wrap up any type of discussion or lecture. Ask for questions from your student audience, and then get a chance to go out and practice in the lab. I want to thank you for your opportunity again today to interview with Sierra College and do a teaching demonstration.